G'day YouTube, Warbles on a lot here. Planning on trying to fit 2 flights of the CC Lee Falcon into one video on this camera, which will be attached to the transmitter. So before I begin flying, here's a bit of an explanation of the aeroplane. Anybody who's used to radio controlled model aeroplanes is used to the idea that they have movable flappy bits on the trailing edges of the wings, and they have more movable flappy bits on the trailing edges of the tail, and that they have little electric servo motors which can alter the position of these flappy bits. So normally when your radio control flyer wants the nose of the plane to go down, they just move the elevator control, and the servo on the plane moves the elevator down, and that deflects airflow, and the horizontal stabilizer makes more upward force, and that lifts the tail of the aeroplane, and the nose goes down, and you get what you ask for. And they can roll to the left and right, and they can yaw to the left, and they can yaw to the right. It's pretty easy for them. And at first glance, the Falcon also seems to have elevators and a tiny weeny little rudder, but it turns out these are ground adjustable trim tabs. That's all they are. The way this thing is guided and controlled is by asymmetric thrust from the 2 electric motors. The fin has enough side area, far enough back behind the centre of pressure and the centre of gravity that it counteracts the side area of the fuselage pod, and in theory it makes it fly straight. The difference in the angle of attack between the tail and the wing is called the décollage, and it means the wing is lifting up while the tail is pushing down. So if the aeroplane goes too fast and it makes too much lift, the tail also makes too much down thrust, and it pushes the tail down, lifts the nose up, the aeroplane slows down, it starts to stall, it makes less lift, and the nose falls down. That's called a stable dynamic instability. Décollage pulls it out of the dives. You'll notice it has high wingtips, polyhedral wingtips. More than one bend in the wing is what polyhedral means. You'll also notice it has flying wires added to stop the wings from clapping hands overhead if it pulls out of too steep a dive. That's because if this thing gets picked up by a thermal, the only possible way you can get it to stick its nose down is to apply, say, right engine, which commences yaw, which means the right wingtip is flying faster than the left wingtip, so it rolls, and because that means the engine is above the nose, it pushes the nose down, and within 3 seconds of giving full left or full right turn, you should be in a vertical dive, which will then stabilise in a powered spiral dive. So that's how I propose to get out of a thermal. Do a half roll and vertical dive and repeat the procedure until I get out of it. May have to do that because I'm going to make one flight without the camera on board. It's the middle of the day, so I can get good lighting conditions for a subsequent flight with the camera. So therefore, on this first flight, using the old battery so you can see how the aeroplane operates, I might have to duck out of a thermal. Just to reiterate, this aeroplane is capable of gliding, which it should go in a straight line, but these days, because of an unknown hidden warp somewhere in that wing, or maybe that one, it glides in right-hand circles. Therefore, some comedian has given it a Coca-Cola trim tab. But I can tell it, let's see the controller there, yep. Full power, turn left, turn right. If full power is engaged, then the turn switch becomes a cutout switch. Pretty simple, isn't it? Okay, well, aeroplane's still switched on. We've just had a gust come through. There's now a bit of a lull in the valley, so hopefully this is going to work. gliding now. Still turning to the right in the glide. See, the only way I can fly in a straight line is to keep using bursts. There we go. I'll now pause that. And as it happens, we do in fact have a bit of a problem. We've broken 2 strands of the flying wires. So we return to the hut for cable repairs, as they say. Okay, so to turn the CC Lee Falcon into the Nokia Falcon Warbledrone, we have to add the Nokia 6120 classic mobile phone, which has a 2 megapixel video camera. We begin by taking 1 rubber band, doubling it and putting it around the left engine nacelle. Wrap it in a figure 8 around the camera. Take another rubber band around the camera, cross it over the flying wire and take it back up on top of the camera. Then, with a 3rd rubber band to put the camera parallel to the rear fuselage, looking slightly down underneath the left wing. Remember, it turns in left-hand circles when it's going up, right-hand circles when it's coming down. All we have to do is make sure that it still balances, which it generally does when the centre of gravity is lined up with the screen junction on this camera. So then all you got to do is start the camera. This camera on. Okay, we're out here in the middle of the day when I don't normally fly, but anyway, let's see how we go. So try to remember to get your hand far enough forward not to get hit by the propeller when you're launching. So, Really does not want to climb. Holy shit. Wacko. There goes one camera and one plane. The fucking wrong stick trying to come out of a turn. Not good country to crash on. So we've busted a propeller, we've thrown the battery out, we've thrown the camera out, but the camera is still recording. Warble's on a lot to YouTube. Ha ha ha. We've loosened the tail rod. Like I said, busted two propellers. Other than that, I think she'll fly again. We shall see. Warble's on a lot to YouTube. The Warbledrone-1 has had a bit of a mishap. Okay, ciao. Postscript, the one test we can do to make sure she's still flyable. So the radio gear still works. It can be repaired. Ciao.